Hello everyone, today we will discuss the chapter on the crop discrimination, its definition and the technologies used for the crop discrimination. First one, we can see the definition of the crop discrimination, or discrimination is also called as differentiation or the classification. The crop discrimination is a necessary step for the most of agriculture monitoring system. The crop discrimination usually is important step for the development and management of the crop monitoring systems. As we have to discriminate or classify or differentiate the crops according to their phenological stages, or according to their the chlorophyll synthesis or the pigmentations, or according to their wavelengths, or the according to their growth stages. We have to characterize or differentiate the crops with the help of the different technologies which we use in the geospatial technologies, and this helps to increase the it is important step for the development and management of the crop monitoring system. Since the remote sensing technology is used for the crop discrimination, both the theory and technological tools have been the constant development. This has led to the remarkable increase in the range of the applications and the scope of crop discrimination techniques. As we know, the remote sensing technology are the sensors which will be used. The sensors can work along with their electromagnetic radiations. In electromagnetic energy radiations is with the help of electromagnetic radiations will be there. The wavelengths of the different crops which will be depends on the synthesis of this pigmentation, which will be there, and different light absorptions or the reflections or the observed. And with the help of, hence the with the help of remote sensing technologies, we have to uh, discriminate the crops uh, uh, with their wavelengths or with their chromosome synthesis or the pigmentation, or the according to their absorption and reflection of the light. Then crop discrimination types using remote sensing techniques are based on the characterization and understanding of the electromagnetic behavior of the target. As we know, the in remote sensing technology based on the electromagnetic energy or solar radiations, which will be discriminate the crops according to based on their characterization, and then this behavior depends on the wavelength at which the crop observation is performed. Due to their remote sensors for the earth observation are designed to operate at wavelengths which will be response of the target, or the crop type is characterized and known, facilitating on this way to target the identification in the sense. As we know, the behavior of these different crops which will have different wavelengths with the according to their observations will be with the help of the remote sensors. We take the observations and discriminate the crops. Then it is important to note the electromagnetic response of the different parts of the crop. Cover not only depends on the wavelength used for the observation, it also shows the variations depending on the season, angle of the incidence of sensor, crop features, illumination intensity, weather phenomena, and topography among the external factors. These are the different variations depending on the for the discrimination of crops, depending on the season, angle of incidence means whatever the radiations are available from the sun, which will be reflected back to the towards the atmosphere. That will be the specific angle of the incidence or the incoming radiations, which will be reach on the crop bodies when there will be the angle of incidence of the uh, radiations. Then crop features also the feature characteristics of these crops will be their different pigmentations or the growth or the different phenological phases. Illumination intensity, whatever the intensity radiations are absorbed by the plants, and then weather phenomena are these are the extreme points to be considered while discriminate of the crops with the help of the remote sensing technologies. And recently RST, that is remote sensing technology and geographical information system, has become a capable role in the agriculture research, predominantly in the crop field prediction, in the addition to crop suitability studies and the site-specific resource allocation. As we know, the GIS and RST technologies are especially used in the R&D research and development, and then predominantly also the estimation of crop yield predictions, then also the addition of suitable crops, suitability of the crop studies, and the site specific resource allocation. Then role of GI, that is geoinformatics, to discriminate different crops at various levels of the classification, monitoring the crop growth and prediction of the crop yield. Then this in short, there will be the discriminant or classification or differentiation of crops with the help of this RST, GIS, or the GI technology, which will be discriminate crops along with their wavelengths, or the according to the incidence of light or illumination of the light, or the season, and then weather phenomenon, and along with this pigmentation of the crops, which will be differentiate according to their wavelengths. This is the definition and detailed concept of the crop discrimination. Next one, we can see the remote sensing technology, which will be used in the crop discrimination. The remote sensing technology is the efficient technology and worth source of the earth source surface information, as it can capture images of the seasonal regionally large area of the earth. As we know, with the help of sensors or with the help of aerial photography included in remote sensing, which can collect the images from the different areas or different crops from the available on the earth. Due to their advancement in the sensor technologies, there will be the high availability of high spatial and as well as spectral resolution imagery, and also the non-imaging spectral radiometers. In case of the remote sensing technology, there are different high spatial, that is geo reference information, or the spectral resolution images, that is spectral means the various different color bands which will be there in the wavelengths, or different wavelength bands there is present in the spectra, which is the spectral resolution imageries are to be collected with the help of aerial photography in the remote sensing. Also, the non-imaging spectroradiometers are also used for the collection of the images. With the help of these imaging and non-imaging data, we can easily characterize or differentiate or discriminate the different crops. Then different crops shows distinct phonological characteristics, that is plant life cycle events, that is called as phenology, and the timing according to their nature of the germination, tillering, flowering, bole formation, ripening, etc. As we differentiate the crops according to their distinct phenology or phonological character, that is their plant cycles, and the timing according to their nature of growth, then also the different uh, pigmentations or the wavelengths or the different growth stages also will be differentiate the crops accordingly. And then even for the same crop and growing season, the duration and magnitude of each phonological stage can be differ between the different varieties. Then also agricultural crops are segmentally better characterized, classified, model, or mapped using the hyperspectral data. In case of the hyperspectral data, there are different bands, that is 100 to 1000 bands number, which will be used for the spectral study or spectral reflectance of the crops, which will be depends on the pigmentation of the crops. Accordingly, we categorize or classify or the model or map the crops. Next one, the feature extraction. Feature extraction is the process of defining image characteristics of the feature, which effectively provides the meaningful information for the image interpretation or classification is called as the feature extraction. As in feature extraction, there will be the meaningful information can be interpreted or manipulated with the help of the images, images accordingly to classify the uh, crops according to these specific image characteristics is called as the feature extraction. The goal of feature extraction are effectiveness and efficiency in classification, then avoiding the extra space of data, the identifying useful spatial as well as spectral features, maximizing the pattern of the crop discrimination. Then crop discrimination spatial features are useful. Crops are planted in rows, either multiple or single rows, as per the crop type to maximize yield. Differences spatial arrangement of the crops gives better spatial information and spatial image classification. These are the major goal of feature extraction, that is effectiveness and efficiency in the crop classification. Because of in feature extraction there will be crops are discriminate or classify according to their images, which will be there with the help of the different colors of the images or the different pigmentation. Accordingly, images can be characterized or the features of this or the image characteristics to be studied in this feature. That's why it is very effectiveness and the efficiency to classify the crops. Then also the avoiding the extra space of the data in this of the feature extraction. Then in feature extraction, identifying the spatial as well as spectral features. Spatial, that is geo reference or geospatial or specific area of the earth should be collect the information accordingly. um, Classification of the specific crop area or the crops, which will be depends on their spectral features, that is different uh, wavelength bands which will present in spectra according to their pigmentation, to classify the crops or discriminate the crops. Then maximizing the pattern of the crop discrimination. In the feature extraction, there will be the maximize the pattern for a classification. Then also the special features are useful. Special features means the specific crops which will be depends collected, whatever the information collected from the specific area of the specific crop should be characterized the images according to their pigmentation or the according to their different colors. This is with the help of these features. The crops are planted in rows, either in the multiple or single rows has to be increased or maximize the crop field with the help of this. And differential spatial arrangement of the crops gives the better spatial information, as the spacing of the crops is varies according to the growth stages of the crops, as the spatial information collected from different crops it will be there for better spatial information for the higher spatial resolution images. The spatial image classification are elements combined with the spectral properties in the crop classification decisions. This is a feature extraction. Then role of texture in classification. Texture means the information of spatial arrangement of colors or the intensity of the image. According to color or the intensity of the images, crops can be discriminated or classified in texture classification. In general, it is possible to distinguish or differentiate the crops between the regular textures by manifested by man-made objects from the irregular manner that natural objects exhibit the texture. In generally texture classification, the crops can be categorized or distinguished or the classify according to their the feature characteristics, that is color of intensity or pigmentation or chlorophyll or spectral features. Hence, the texture classification can be used to discriminate the crops. For the crop discrimination, remote sense data, conventional texture analysis, and the gray level co-occurrence matrix, that is GLCM methods are used. Next one you can see uh, gray level co-occurrence matrix. In case of the gray level co-occurrence matrix, that is GLCM. In GLCM method describing the gray value relationship, in this concept, according to the gray color or gray value of the crops will be categorize the crops accordingly. And GLCM is a statistical method for examining the texture. This is an important method for analysis of texture for the classification of the crops. According to the gray value relationship, crops can be distinguished. Then GSM can be used in two-dimensional histogram, that is rectangles of the frequency which will pair with the gray level pixels or the images occur in the given spatial relationship. In this GSM method, the two-dimensional histograms are prepared over the rectangulars with their pairs, which can be made with the gray level pixel means the smallest units of the image, which will be image can be divided into different sub units called like the pixel, which will be go or should be studied with their help of pairs of different gray colors, and then accordingly distinguish the crops. In GSM method is way of extracting the texture features. An image composed of pixels each with the intensity that is specific gray level, and the GSM and we differentiate the combination of gray level co-occur in the image or the image sections. This is a gray level co-occurrence matrix. Accordingly, gray level relationship or accordingly histograms. This is a statistical method to analyze the image classification according to the histograms or rectangulars are made with their pairs are or compared with their gray level intensity or matrix, which will be easily to characterize the crops. Next one, the local binary pattern, that is LBP. It is a powerful feature for texture classification. Local binary pattern is an effective for the texture classification also, and in this case the two images are threshold or combinedly together, and then afterwards the coding of these image mm, images or the pixels of the images or the smallest units of the image is called as the pixel. The images can be converted or divided into the small unit, that is pixel. The pixels, after dividing the images, both images are combined together, that is thresholding the images with the help of this computer program, and can be start the coding, that is binary code, that is from the center of the pixel, that is the lowest number, and the end of this coding, that is the highest number, and accordingly the both images they are combinedly, which will be rotated in a clockwise direction with the help of this computer device. And then afterwards we will get the 12, 8 or 6 digit binary number, and that is binary number. Accordingly binary number we should classify or the categorize or differentiate the crop, uh, differentiate the crops. And due to the discriminate power, LBP, the local binary pattern texture operator, has become popular approach in various applications. Next one we can see the band selection. The band is specifically related with the spectral bands, which will be the different wavelengths, the spectra or the spectral features, which will be studied accordingly for the crop classification. In the band selection, there is two important steps which will be there, that is hyperspectral bands and the multispectral bands. Then in case of the hyperspectral bands, especially used in the remote sensing technology, there are these spectral bands only depends. Spectral bands means the in light or energy passes desired according to their wavelengths. The multispectral, hyperspectral. Multispectral band means 3 to 10 band numbers, and then so hyperspectral, that is 100 or 1000 number of bands of the remote sensing. These two technologies are used for the band selection and the spectral band analysis, and there are two consequential different approaches of the band selection, that is supervised and supervised classification. The supervised classification, which will be the where the manually which will be calculate or differentiate the crops according to their growth stages or the characteristics or the size of leaf or area of the leaf or the color of flower. Accordingly we can classify the crops or discriminate the crops. But in case of the unsupervised classification, which will be there, the digital devices can be used which will discriminate the crops accordingly. And these due to the availability of the hundreds of spectral bands, and there may be some values in the several bands which increases data redundancy. This redundancy means the additional space will be considered, and to avoid this extra space and to get distinct features from the available hundreds of band, we have to choose the specific band by studying the spectral reflectance behavior of the crops. In the band selection, which will be different types of band, that is multispectral, hyperspectral bands. These multispectral and hyperspectral bands, which will be majorly used for the study of the wavelengths or the spectral bands of the specific crops and accordingly to classify or discriminate the crops. Next one you can see number two, that is narrow band vegetative indices. The spectral indices assumes that the combined interaction between the small and the number of the wavelengths inadequate to describe the biochemical biophysical interactions between light and matter. This is a spectral indices which will be studied according to their biochemical or biophysical changes in the crops, which will be depends on the light and the other resources. In this narrow spectral vegetative indices, where the hyperspectral system is used, that is the ability to integrate wavelengths not sampled by any broadband system, but to quantify the absorptions of the light to be specific for the important biochemical and biophysical quantities of the vegetation. Vegetation properties, that is measured in the hyperspectral vegetative indices, that is HVI. That is HVI can be divided into three main categories, that is structural properties, then biochemical properties, then physiological and trace, then narrow band vegetative indices. There are different types of the uh, hyperspectral vegetative indices. That is first structural properties. This property include the green leaf biomass, leaf area index, and the fraction of photosynthetically active radiation, that is FPAR, which will be considered for the uh, characterize the differentiation of the crops according to their vegetation properties, that is green leaf biomass quantity, leaf area index according to the crops changes the leaf area index. Different crops have different leaf area index, and then accordingly fraction of photosynthetically active radiations, which will be have the different crops have different FAR. It will be easily to characterize the crops or the differentiate the crops. Then second one, biochemical properties like the water pigmentation. That is pigment means chlorophyll, carotenoids, anthocyanins, other nitrogen rich compounds like protein, plant structural material like lignin and cellulose. These are the different biochemical properties which will be easily to useful for the characterize or differentiate the crops. And then physiological and trace indices, which will be the trace induced stages or change in the xanthophylls, change in chlorophyll content, and change in soil moisture. Accordingly, differentiation of the chlorophyll content will be characterize the or classify the crops. The narrow band vegetation indices. Then it can be used as potential variables for the crop type discrimination and the best vegetative indices of the different category to discriminate the crop type, which will be depends on the greenness or leaf pigment indices, chlorophyll rate is indices, light use efficiency, and leaf water indices. These are the different major parameters which will be used for the narrow band vegetative indices, which will include for the discrimination of crops. Then importance of hyperspectral remote sensing. HRS, that is advanced tool for the provides high spatial and spectral resolution data from a distance with the aim of providing near laboratory quality reliance for each picture elements or pixel from a distance. That is HRS, which will be majorly used in remote sensing. Technologies are used to study the or collect the high spatial and spectral images, which will be aim of providing the near laboratory quality or quality reliance or the data of each pixel or the picture from a specific distance. The recent advances in remote sensing and geographic, that is GIS system, has led to the way for the development of the hyperspectral sensors, are the sensors which majorly in the remote sensing. The hyperspectral remote sensing technology are also known as imaging spectroscopy, that is study of visual light, and the relatively new technology that is currently being investigated by the researcher and scientists with regard to the detection and identification of the minerals, then terrestrial vegetation, and the man-made material and the backgrounds, where you can see the hyperspectral remote sensing technology, which is also called as image spectroscopy, which will be used for the majorly by the scientists and the researchers for the collection of data or detection of these minerals, identification of the minerals, terrestrial vegetation identification or classification, and the man-made materials which and the backgrounds which will be studied with the help of hyperspectral remote sensing. Then hyperspectral remote sensing combines imaging and the spectroscopy in the single system, which will often include large data sets and requires new processing methods. With the help of this HRS, we have to combine the imaging or the aerial photography and the spectroscopy, which will be useful for the processing of the large data. Then hyperspectral datasets are generally composed of about 100 to 200 spectral bands of relatively narrow bandwidths, that is 5 to 10 nanometer, whereas the multispectral datasets which will be composed of 5 to 10 bands of the relatively large bandwidths, that is 70 to 400 nanometer. Okay, where we can see the different uh, between difference between the hyperspectral data sets and the multispectral data sets. The number of bands and then bandwidths are the varies with each other. Then hyperspectral remote sensing, that is HRS, and imaging spectroscopy, that is IS, are two technologies that can provide detailed spectral information from every pixel of the image. Spectral information means this according to the spectral color or the bands the present on the spectra, which will be depends on the pixel of the images. That is, images are divided into the subunits called like the pixel accordingly, which can be characterize the classify the crops with the help of HRS. This is the importance of HRS or the hyperspectral remote sensing. Next one we can see the okay, thank you. This is the today's topic.